All right, so let's look at number 6. It says, find the volume of the solid generated by revolving the region bounded by the graph, so the equation about the x-axis. So we have 4 different graphs, per se, that are going to create this bounded region, and then we're going to revolve it around the x-axis. So let's go ahead and begin, okay? So I have on my iPad these 4 equations, and then again, what we're going to do is we're going to revolve about the x-axis. So let's go ahead and draw this first one. Y is equal to x squared plus 1. Okay, so I'm going to come over here. Whoops, not erasing it. But we're going to draw this in red to match up. There's my x squared plus 1, which is shifted up 1 unit. And then it's going to come over here as well. Okay, so there's my x squared plus 1. And then now we're going to do this negative x squared plus 2x plus 5. Now let's go to the calculator for this so that we can see the graph a little bit faster. So negative x squared plus 2x plus 5. There it is. It looks like the vertex is at 1 and almost like 6.7. So 1, 6.7, and then negative 1.5 and 3.5. Okay, so let's come over here. And with our blue, we're going to say like negative 1.5 is here. Whoops, did it again. And our 3.5 is going to be like 1, 2, 3, and then 0.5 is about here. So negative 1.5 is here, and then 3.5 is over there to the right. Let me do that a little bit cleaner. So we'll say 1.5 and 1, 2, 3.5. And again, we saw that the vertex was about 1, and like way over here about 6.7 is the vertex. So that our graph is going to look something like the following. Okay, so if I were to go ahead and put x squared, so let me press tab. Whoops. Let me press tab again. And then let's do x squared. There's our x squared graph, but it was an x squared plus 1 is what it was. So we'll say plus 1, shift it up 1 unit. And then you see that there's going to be like about negative 1 and maybe like 2 is where the intersections are going to occur. Okay, let me move these out of the way. And I'm going to do that on the original document here to find when those are equal to one another. Okay, so I'll say menu 3.1. And I'm going to say, when was the first function equal to the second function? Because I've already used my graphing feature, I'm going to go ahead and put f1 of x. That's my blue function. When is it equal to f2 of x? That was my red function, my x squared plus 1. Okay, and I'm going to say comma x. In other words, solve for those x's. And right there you see, because I have this stored, it was bolded whenever I put in f of 1. So it's not bolded until I've identified f1 because I have that stored over here as far as the functions that I'm dealing with. So remember, these pages talk to one another. So at negative 1 and 2, just like what we thought by the graph, but again, we have to verify with the calculator, negative 1 and 2 are the points of intersection. So let's go ahead and write those in. So we'll say here, let me do that in black, it's going to be at negative 1. And then here at 2 is going to be where they intersect. So it's a little bit off as far as like the graph is concerned, just a little bit off as far as like the red graph. And what I can do just to make it a little clearer is kind of take that one off and clean it up just a little bit. So we want to draw x plus 1, but that it crosses here and that it crosses wherever 2 is at. So again, 2 on the graph was located just a little bit to the right. Let me move this down, just a little bit to the right of the vertex. Okay, so we're just trying to get a little clearer with right there about where 2 lines up. Okay, just a little bit clear with the drawing. So we go over here and it looks something, let me clean that up, like that. Okay, so let's shade our region bounded between the 2 functions. Actually, we have to look at x is equal to 0, which is the y-axis. Okay, and then x is equal to 3. Okay, x is equal to 3 by the graph is going to be way over here I don't know why people are commenting on those videos. But anyway, x is equal to 3 is going to be over here to the right, somewhere about here. Okay, so it's going to create some kind of other area, if you will, over here to the right side. Okay, so let's go ahead and go to the graph and show that. So x is equal to 3 is going to be roughly about here. And you see that it shows another shaded region. Okay, so let me go ahead, clean this up just a little bit. And then we will shade both regions that are bounded. Okay, so we have this region here between the red, blue, and green. And then between this red, blue, and green, we have this other region right here. So we have two regions that are going to revolve about the x-axis. Okay, so this one's going to come out of your page, kind of go dip underneath the x-axis. And this one too is going to go out of the page, kind of dip underneath the x-axis. So we have these vertical slices, otherwise parallel to the y-axis. Therefore, they're going to be two pieces, two separate integrals. One for this first one here in orange, if you will, and then this other one that is in blue, showing the volumes of each piece. Okay, so I will revolve, or actually rewind this just a little bit. And then I have two integrals. So I'm going to build them real quick. And they're both dx's because they are parallel to the y-axis. And they both of them, because of this void, all of this empty space down here, they're going to be washer method. Okay, because again, your axis of revolution is the x-axis, which is right here. Okay. So washer method for the first one is going to be, it's going to be big pi r squared minus little r squared. This is a pi. And then this one is also a washer method. So you have the big pi r squared minus the little pi r squared. And yes, we are GCFing out that pi constant multiple rule so that you could see it's just big r squared minus little r squared. All right. So now we could do bounds. I'm going to go ahead and do bounds first this time, and then I'll work with the functions at the end. Okay, so this first one, we know it's going to be from 0 all the way to wherever this intersects here. Okay, so that's at 2 is what we found it to intersect before. So we're going to say from 0 to 2. And then we go from that 2 all the way to this other x equals 3 equation. So it's going to be 2 to 3. So from 0 to 2 is the first one, and then from 2 to 3 is the second one. Okay, so let me go ahead and undo these to make room for my functions so that you can see them here in just a bit. Okay, so let's do this first region. I'm going to look for big R, and that's going to come from the axis of revolution first. And then we're going to go from that x-axis to the outermost function of that shaded region, okay? And it touches the blue function here, and it touches the x-axis here. Now, we are interpreting the top because we're looking as normal. We're not rotating our heads because this isn't dy, this is dx. It's the easier one, okay? So looking at this green function that I just drew, my top function is this blue y equals negative x squared, so on and so forth. Okay, so for the sake of this video and for the sake of not running out of room, I'm going to label this, and you can do this on the AP exam, f of x, and I'm going to label this g of x. We're going to say let f of x equal that, and let g of x equal that. Because then over here, if it's the free response questions that you're working with, you could just say the blue function is going to subtract the bottom function, which in this case is the x-axis. So you're going to say minus 0. And that right there is that green piece that we showed was the big R. Okay? So now let's do the little radius. We're going to go again from the axis of rotation. And then we're going to go all the way until we touch the innermost function. Okay, so that's the red that's going to be right here. And then it's still the x-axis. And again, when I'm looking at it from top minus bottom, the red function this time is the top, so I'll put f of x. And then the bottom function is still 0, so I'll put minus 0. Okay, so our first integral is done. After we find the second one, then we're just going to add them up together and be done with it. Okay, so let's go ahead and set up the second one. Okay, so let's go to somewhere over here where this shaded region is at, and we're still revolving about the x-axis. Okay, so we're going to create this straight line from the axis of rotation, which is the x-axis, and going to the outermost function. Okay, the outermost function still of that region bounded, of that orange shaded region bounded. Okay, so the top function here is the red function, and the bottom function here is now the blue y equals 0, the x-axis. It's still the x-axis. So what's the length of this green line that you see? Well, it's going to be the top minus the bottom, which is still the x-axis, so it's minus 0. Okay, and again, just a reminder, this entire equation right here, x plus 1, is going to go right here if you were to type it into the calculator, or you can write it notation as far as like f of x, the way I'm showing you right here in these notes. But at the same time, I'll show you in just a bit how you can save that for your calculator. And then yes, all of this is going to be your blue function, or your g of x. And yes, you would have replaced that here, and then you're going to replace it over here in just a bit. Okay, so let's go from the axis of rotation, from the x-axis, all the way to the innermost function, which in this case will touch blue right about there. Okay, so let me get the black pen. Right there, it's going to touch the blue function, because I know I have a lot of shading going on, but it would come right here like that. And then the bottom function is still 0. Okay, so it's going to be this g of x, and then it's going to be minus 0. Okay, so when I get each individual integral answer and then I add them up, that'll be my final total answer altogether. Okay, so let me go ahead and show you how you can do this with the calculator quickly. Okay, so we know we already have f1 is this one here and f2 is this one. But let's say we didn't use the graph. Okay, menu 1.4 clears all storage, so now nothing is stored, and menu 1.5 gives me a nice blank page. Okay, so I'm going to go ahead and put, what if I looked at it like x squared plus 1, and I save this as my f of x. Okay, the reason why I'm doing that is what I did over here. X squared plus 1 is f of x. And then the other function, which is negative x squared, which is negative x squared plus 2x plus 5, I'm going to control store this as g of x. Okay, and again, that's all this function is stored now as g of x, because that's what I named it. Now all I have to do is just type all of this in, and I'm good to go. I could do 2 problems, which I'm going to do for the sake of instruction. So I'm going to do this Washer method of pi, and then it's multiplied with the integral. And the first one was from 0 to 2. Okay, yeah, from 0 to 2. And then now, because I stored this, I'm going to be able to do big pi r squared minus little pi r squared. Okay, again, that pi is GCF'd out in front. Okay, so now we're going to say g of x minus 0. And that's what we did over here for top minus bottom. And now we're going to do minus f of x minus 0. Remember, it's big pi r squared minus little pi r squared. Okay, so let's go ahead and, let's go back over here, and we're going to put f of x, again, like we stored it, minus 0. This right here is the first shaded region. They are parallel to the y-axis, so they're dx's. My answer would be 152 pi over 3. That's just for the first shaded region. Okay, so when I do it again for the second region, the way we wrote out on the other page, we're going to have multiplied with the integral from 2 to 3. And this time it's big R squared minus little r squared. Whoops. It is still dx. And then this time it's f of x minus 0. So you could just put f of x if you want. I'm just going to do minus 0. And then over here we have g of x minus 0. So g of x minus 0. And we get that. So now if I press enter to copy it and then add, scroll up, press enter to copy this, my final answer for this particular example would be 277. I'm going to write this over here on this other page, pi over 3 units cubed. Okay, so let me show you that. 277 pi over 3 units cubed. Okay. Again, make sure that whenever you are setting this up, if you do need to use a calculator as far as the graphing feature, just to kind of see where those points of intersections lie, please feel free to do so. But yes, also, because that'll help you as far as knowing how many different shaded regions there are, rather than kind of just guessing and checking, okay? But nonetheless, that's how you do number 6. All right.